Hello guys, myself Ankita. In this video, we shall see another problem on LeetCode, matrix diagonal sum. So given a square matrix mat, return the sum of matrix diagonals. Only include sum of all the elements on the primary diagonal and all elements of the secondary diagonal that are not part of the primary diagonal. So what the given question is, they have given a matrix and we have to just find the sum of all the elements of the diagonal. So how do we do that? And before going into the problem, look into this example. We have two diagonals, right? In every matrix, one is primary and other is secondary diagonal. So for the primary diagonal, you just need to find sum of all the elements. But when it comes to the secondary diagonal, they have given the condition only include the sum of all elements of the primary diagonal. Yeah, fine. And all the elements of the secondary diagonal that are not part of the primary diagonal. So if you look into the secondary diagonal, 3, okay, 5, this 5 element is present in the primary diagonal as well. So when you find the sum of the secondary diagonal, when you solve find the sum of the secondary diagonal, you just need to neglect this element because it's present already in the primary diagonal. It makes sense, right? You just need to find sum of all the elements of the diagonal. So why do we need to find this element sum as twice? If you include for primary diagonal, it will be 1 plus 5 plus 10. Again, if you include this 5 for the secondary diagonal, it will be 3 plus 5 plus 7. So 5 will be added twice. That should not be done. So that's how the problem works. So give an example 159 primary diagonal, for secondary diagonal 3 and 7, and that equals to 25. So we'll take the same example 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are the diagonal elements and it has I equal to 0, I equal to 1 and I equal to 2, j equal to 0, j equal to 1 and j equal to 2. So now this is primary diagonal and this is secondary diagonal. So let's consider the primary diagonal first. So in the primary diagonal, we have the elements 1, 5, 9. So if you observe, this 1 is present in I equal to 0, j equal to 0, and 5 is present in I equal to 1, j equal to 1. Sorry. Similarly, 9 is present in I equal to 2 and j equal to 2. So if you look into this element position carefully, when I and j are equal, they are the elements of the primary diagonal. So you just when you initialize sum equal to 0 and I is also equal to 0 and j is also equal to 0. So while I lesser than mat dot length, let's say it's n, mat dot length will be equal because for since it's a square matrix, both row and column length will be equal, so it's fine. So while I lesser than n, you just do the summation sum plus equals to mat of I comma j. Then you do I plus plus and j plus plus. So initially I will be 0, j will be 0, fine. Then you find the summation sum plus equals to 1. Then again you do I plus plus j plus plus. So it will give 1 comma 1. From 0 0 it will be raised to 1 1. Then again you do the summation. Then again you increment I plus plus j plus plus. We both become 2. Again you do the summation. So if I equal to j, that means it's a diagonal element. And that to particular it's a primary diagonal element. And you do the summation and you return the sum. Finally, by this end of while loop, you'll be having sum of the primary diagonal. So what should we do for the secondary diagonal then? So coming to the secondary diagonal, again, this time let's take secondary diagonal elements 3, 5, and 7. So 3 comes in I equal to 2, j equal to I equal to 0 and j equal to 2. And 5 comes in I equal to 1, j equal to 1. And 7 comes in I equal to 2 but j equal to 0. Last row, first column. So if you observe, since 5 is already the primary diagonal, we should neglect 5 this time. So for neglecting 5 this time, if you see the element position, in this case I is not equal to j, here I is equal to j, here I is not equal to j. So in this case I is equal to j. So while running the for loop, same thing when you do, just give the condition if I is not equal to j. If I is not equal to j, then add the summation. Sum plus equals to again same thing. And this time I should be initialized with since secondary diagonal start from this upper end top right to the bottom left. No? So top right will be nothing but I equal to 0, first row, and the last column. Last column is nothing but j equal to 2. J equal to 2 means j will be equal to n minus 1. So length 3 minus 1. N is nothing but mat dot length here. So 3 minus 1. So you start from I equal to 0, j equal to n minus 1, right? So that will be nothing but 0, comma 2 only. 0, comma n minus 1. Then if you observe 0, 1, 2, I is incrementing, but when it comes to j, j will be decrementing 2, 1, 0. Right. So initially will be in zeroth row, then first row, then second row. But j last column, second column, first column. So that's why I will be incrementing each iteration. I will be incrementing, but j will be decrementing. That's it. We will just code this. So initially, as I said, int n equal to mat dot length. It's a square matrix, so both row column length are equal. Then int sum equal to 0. And int I equal to 0 and int j equal to 0. This is for the primary diagonal. So we'll start with the primary diagonal. While I lesser than n, sum plus equals mat of I, comma j. So after this, I plus plus j plus plus. So that you start with I equal to 0, j equal to 0. Then I plus plus j plus both will be 1. So we will fetch 5. Then I plus plus j plus plus for the next iteration, you fetch 9. I equal to 2, j equal to 2. So by the end of this loop, you will have sum of the primary diagonal. Now let's start for the secondary diagonal. For the secondary diagonal calculation, again you have to initialize I and j. So I will be first row and j will be last column. So I equal to 0, first row, and j will be last column is nothing but n minus 1. My dot length minus 1. This is for the secondary diagonal. So now again run the while loop. While I lesser than n. So by this time you have to check for the condition if I is not equal to j, because if I is equal to j, that means that element is already in the primary diagonal. So if I is not equal to j, so in this case 5, I is equal to j, but 3 and 7, I is not equal to j. So yeah, if I is not equal to j, then do the summation. So I comma j, mat of I comma j. And after at each iteration, you do I plus plus and j minus minus. So why I plus plus? You are starting from the 0th row to the second row. J minus minus from second row to the 0th, second column to the 0th column. Fine. At last, you return the sum whatever we have got. We will run this. Sum plus equals, it should be, yeah. Okay, we will submit this. Yes, successfully submitted. If you have any notes, please drop it in the comment section. We'll come up with another video in the next session. Until then, keep learning and please subscribe to the channel. Thank you.